Right, this is example 2 from 1 a day 27 for math 230. In this example, we're looking at finding the uh, region that is below or above the x-axis, so y equals 0, and bounded by these two curves. Okay, so to do that, let's first get a picture of what does this region look like. So this is a horizontal line that has an x-intercept of 2. It looks something maybe like that, closer to 2. This is a parabola, which has intercepts at 0 and 4. So it's going to be something like that. And above the x-axis, that's where y equals 0. Okay, so the region that we're looking at is this area here. And we're going to find the area using the double integral. Okay, so our vertical stripe will look like that. And so you'll notice here it's going to be two different integrals. So we're going to have to break this up into the sum of the integrals where the bottom curve is this line here. This is y equals 6 minus 3x. And then obviously the last case from this point 2 onward, the vertical stripe there is going to be just the area under this curve. Okay, so the vertical we'll do first since we kind of already started there. So the vertical stripe. Okay, so the vertical stripe, we know that we're looking for the area, according to Fubini's theorem, is going to be between, well, this is going to be, what do they mean? Looks like at x equals 1, but just to make sure, 4x squared minus x squared equals 6 minus 3x. Oh, that's not 4x squared, that's 4x minus 6x squared. There we go. Okay, so let's move everything over. So we get 0 is equal to x squared. I'm going to subtract, so that's going to give me a minus 7x, sorry, plus 6. Okay, so that's going to be what? 0 equals x minus 6, x minus 1. So either x equals 6 or x equals 1. X equals 6 is clearly outside of our domain here. So we're going to use this as x equals 1. So it says x equals 1. And then it switches at where it looks like the y or the x-intercept. So the x-intercept for 6 minus 3x, which is at x equals 2. So if this equals 0, then 6 minus 3x. What is that? If x is equal to 2 here. That's pretty obvious. So this first one is going to go from 0 to 2. And if you look at what is the upper function here? So that's the first part. Okay. Then the upper function is going to be the 4x minus x squared. Okay. And that's what y equals. And then the bottom part here is going to be y equals 6 minus 3x. Okay. So that's this part. And then we're going to have dy dx. And then we're going to add to that the value here. The other side is going to go from 2 to 4, which is the x-intercept of the function there, with the upper going to be just the 4x minus x squared, and the lower can be 0 there. Okay, and so it's going to be dy dx. Okay, computing the integrals here, this is pretty straightforward. This is just the integral of dy. So you add that, so you're going to get, okay, so let's do it real quick. You're going to get y evaluated from 6 minus 3x to 4x minus x squared dx. Okay, and then you integrate that, do the substitution, subtract, and then compute. And likewise over here, the integral from 0, that's at 2 to the 4 of 4x minus x squared. That one's really easy to do because the lower limit is 0 there. Okay, and then if you compute this out all the way and finish up the algebra there, you're going to get 15 over 2. I'll save that part just because the setup is really the important part here. So with the vertical strips, we get that the area is 15 halves. Okay, so now let's look at the horizontal stripes and see what values we get there. So I'll try to illustrate those with a blue rectangle to kind of highlight, some of maybe the subtle differences here. So likewise, you're going to see that there's one here. This is a rectangle. Blue. So this is the horizontal stripe. And so you're going to see right here, there's a point where um, the lower and upper curve for the horizontal are going to end up switching signs. So we're going to have to break up this region into two separate integrals as well. And we can figure that out by just observing what is the lower function and what is the upper function. Okay. With respect to x being where x is measured this way is the height of the function in terms of y. So this is x of y for the horizontal. Okay, so for the horizontal stripe. Okay, so this is the vertical. So we're going to have a very similar situation. We're going to have area. Okay, so from this one, then the top of the function, okay, I guess we should start at the bottom here and move up. So the integral from here is going to be the upper value minus the lower value. Okay. So we're going to go from the value here, which is where y equals 0, to this point here. So that we're counting along this range. But we're kind of going this way, so you got to maybe flip your head a little bit. We're going to go up to where these two curves cross, where they intersect there. And so we saw that that was when x equals 1, which means that if we invert and solve the other direction, we get that that's equal to 3. In other words, plug in okay. So 6 minus 3 times 1, y is equal to, so that gives me 3. So that's the that's the height of this value. This is y equals 3. That's the point where those two intersect, and that's the point where those shift. So this is going to be from 0 to y equals 3 integral. And now this point here, what is the upper function? Well, the upper function is that quadratic. But remember, this is solved in terms of x. We need to solve this for y. And so to do that, let's see, we have y is equal to 4x minus x squared. To solve that for y, you can do a couple of things. Completing the square might be one method. We can go about doing that. So we add 4 to both sides, taking half of this and adding it to both sides to get y plus 4. Well, first, because of the signs, I'm going to go ahead and multiply everything through by negative. That'll make it a little bit easier. And then I take half of this and add it to both. So to complete the square, just divide this by 2, add the square to both sides, and that creates the perfect square here. Then we take the square root and you get plus or minus the square root of 4 minus y. And then if I add 2 to both sides, then you get the final result there. Okay. So that gives us then for our this would be the upper branch of so this would be the positive one. And our lower one would be the function there. So that's going to be, if we solve that we didn't do that yet either, huh? So y equals 6 minus 3x. So subtract y minus 6 divided by 3 equals x. So y over 3 minus 2 is equal to x. So that's going to be our lower limit. So x is going to equal 2 minus y over 3. And then we're going to have the upper branch on this first part. If you can kind of see, you can kind of see that the quadratic is opening this way. So this would be the upper branch, and that would be the lower branch. We're going to have 2 plus the square root of 4 minus y dy dx. No, dy. Yeah. dx dy. I was looking at the y's and thinking x's. Okay. So that will be the first branch, and then from above there, then we have plus the integral from 3 to uh, the vertex of the parabola here. Okay, so um, we know that y equals 6, not 6, sorry, 4x minus x squared. So this term is my b term, and that's my a term. So this is going to be the x coordinate is negative b over 2a, which is equal to negative 4 over 2 times negative 1, which gives me a positive 2. Okay, so then what does that mean for the y value? So we plug that in, we get 4 times 2 minus 4. Uh, looks like it's going to be 4. Okay, so this is going to be the integral from 0 to 4. That's the vertex, that's the last horizontal location or the last value there. And now here it's going to be interesting because it's going to be the bottom of the vertex for the inner integral minus uh, it looks like it's just be minus this horizontal line at x equals 1. And so right here, so it's going to be, actually it's going to be the top minus the bottom of the vertex. Okay, there we go. So it's going to be 2 minus the square root of the 4 minus pi. And then this is going to be 2 plus the square root of 4 minus 5. Okay, dx dy. Yeah. All right, so you can see here from where x equals 1, the uh, y equals 3 to y equals 4. This region here, okay, the horizontal stripe, if you see it there, going to have the upper function minus the lower function for the limits of integration. So this is the upper curve and it's the lower curve of the vertex, which we saw for down here. Okay. If you compute these integrals out, you're going to get that the resulting area is 15 over 2, as you would expect. Um, the region is the same, so the corresponding area is the same as well. Two different methods to get the same result. You can choose which one means the most or makes the most sense to you. But I hope that was helpful, and I'll see you in the next